Okay. All right, so let's say we want to solve this equation. Okay? Absolute value of x plus 3 minus 4 equals 2. We could do that by hand, right? You'd add 4 to both sides, then you split into your positive and negative path, okay? But if we do this using a graph, here's how we would do it. We're going to graph the function that makes up the left side of the equation, okay? Typically, when you've ever done this before, you've done it on Desmos, and we're just going to actually do this with our own pencil, okay? So this is the left side of the equal sign, so I'm going to graph this function. This is a good review. This is our absolute value function shifted left 3 and down 4. So left 3, down 4, 1, 2, 3, 4. And then it has a slope of 1 because there's no other a value. So up 1, right 1. It's at negative 3, negative 4. The vertex is at negative 3, negative 4. And on the other side of the vertex, we have a slope of negative 1. Get a ruler. I do not trust my abilities to draw a freehand straight line. Okay. Okay. All right, then we want to graph the function that makes up the right side of the equation, y equals 2. Okay, so the right side of the equal sign is just 2, so we're going to graph the line y equals 2. That has a y-intercept of 2 and a slope of 0. So it's just this horizontal line with a y-intercept of 2. Okay. Okay, so this is y equals 2. And this guy is y equals absolute value x plus 3 minus 4. Okay, so if I'm using a graph to solve an equation, it's sort of like a system, except the way we write our answer is different from a system. So we're going to find the point of intersection, and the x values are the solutions. Why only the x values? Because the original problem was just solving for x. Okay, so I'm going to find where those intersect, there and there. Okay. The x values are the solution. So we got to figure out what are the x values there. So the first one looks like it's at negative 9. And where's the other one? 1, 2, 3. Okay, so the two solutions are negative 9 and 3. If I had solved this on paper, algebraically, I would have gotten the exact same answers. Okay? Okay. Now, if we make it an inequality, okay? So this is the stuff we did yesterday. If I want to solve this inequality, same functions, except instead of an equal sign, I got a greater than sign. Okay? So we want to identify whether we want the part of the function above, greater than, or below, less than the line. Which one do we want? Do we want the part that's above or below? In other words, what's this symbol? That's a greater than, so we want the part that's above the line. Okay? Okay, now, to know, I don't think my pen is dark enough to show up, so let me grab a different one real quick. Here we go. Okay, so above the line, that's the one we want. Okay, so if I look at my inequality symbol, I have to decide, does that mean a closed or open circle? There's no bar underneath, it's an open circle, right? So at my intersections, I would have an open circle, and I would want the part that's above the line. So that's this part right here, right? I know I'm using a whole lot of color, and if you think that's helpful, please do that. Otherwise, I didn't put any out because I'm using a whole lot. Okay? So that's the part that's above our line. Okay, but remember from yesterday, our number line answers, right? I was going to show the notes from yesterday. Do I have it? Yeah, right here. Our answers go on a number line, not a two-dimensional graph. So what we can do is we can take this and turn it into a number line. So if I were to flatten out this graph, right, take the height out of it, wouldn't it look something like this? Right? Imagine you took this and squished it so there was no height at all. It was just left and right. It would look something like that. Well, what are those numbers? -9 and 3, right? Okay, so then we would write our solution set, and the way we write the solution set is just like we did these. You can either do it in set notation or interval notation, okay? You pick the one that makes sense to you. I'm going to do them both. So in set notation, it would look like x is less than -9, or x is greater than 3. And in interval notation, I have two intervals. The first interval begins in -infinity because it's an arrow, right? And ends in an open circle of -9. Remember, open circles and infinities always get parentheses. And then when I have another interval, I have to join those two intervals together with a U for union. It just lets us know that both intervals are are answers to the same question. Union, parentheses 3 to infinity. Okay, so you don't have to give both notations. You just have to know one and give that one. Okay? Okay, so now let's say that we want to solve a different inequality. And do me a favor, I could not put this on, I could not type this. The program wouldn't let me. Can you add a bar underneath that inequality so it's less than or equal to? I could only do a less than for some reason. I'm sure there was a way, I just couldn't figure it out. Okay, so same problem, but I want to find less than or equal to 2. Okay, so identify whether we want the part of the function above or below our line. Well, if it's less than, logic says I want the part below the line, right? Okay, and since it's got an equal, my symbol has an equal to, that means I'm going to have a closed circle. Okay, so when I come up here, my endpoints, and then all the part of the function that's below the line, isn't that this part right here? The intersections is the equal to, and then this part is the below. Okay, now if I flatten that out to where it's just on a number line, it's that part in between, right? Remember, we either have an innie or an outie. This one's an in. Okay, so if we write the solution set in set notation, it would look like this. It would look like negative 9 is less than or equal to x is less than or equal to 3. Okay, this literally means x is in between negative 9 and 3. And then in interval notation, it would look like bracket, negative 9, comma, 3, bracket. Brackets because they are both closed circles. Okay? So we're going to have a one or the other kind of situation. Okay? You're going to have an innie or an outie. Is this easier than solving algebraically? What if you didn't have to put the graph? What if the graph was already there for you? That would be easier, right? Okay. Well, this, right now, that's the only time you're going to have to graph it yourself and get the answer. Every other time, we're going to look at a graph that's already there. Or you're going to type it in Desmos, one of the two. Okay? So let's do some examples, and we're not going to have to make the graph. It's already here. Okay. All right, so example 2 says, let f of x equal absolute value of x minus 4 plus 1. That's this V-shaped guy right there. Then solve f of x equals 5. All right, so this line right here, this is the line y equals 5. Okay, so if it's an equal sign, I would just want intersection. Where do these intersect? And we're just going to give the x coordinates. Okay? So it's just two numbers, right? So figure out what those x values are. 0 and, is that 8? 3, 4, 5, 6, yeah, 8. So 0 and 8. Those are our two solutions. Whoops, I wrote that in the wrong spot. I'm sorry. Thank God for erasable pen. I meant to put that up here. 0 and 8. That's the equation. Okay. All right, now if I want to solve when x is less than 5, less than, there's no equal to bar, so it's an open circle, and less than means the part that is below our line. So open circle and below. So that's this part right here, right? Okay, now we state our answer. Our answer in set notation, it would look like 0 is less than x is less than 8. Ooh, that was a terrible curly brace. I'm sorry. I'm on the struggle bus. Or in interval notation, it would be parentheses 0, comma 8, parentheses. So this is set notation, this is interval. We know why we're using parentheses in our interval notation? Because of our open circles. Okay, if I want to solve f of x is greater than 5, that is the stuff that is above the line. So this means also open circle, but this one is the part that is above. So open circle, above. So that is our two separate intervals. Oh, I didn't do a number line out of that first one, but it's okay. I'll just do a number line out of this one. And then that's the outie situation, right? So that would be x is less than 0, or x is greater than 8. Or we could say negative infinity to 0, union 8 to infinity. Okay? Okay, so what questions can I answer for you so far? Nothing yet? Okay. Okay, example 3 is kind of weird. Okay? Let f of x equal this absolute value function. Okay, so it's reflected, shifted left 1, up 6. Yep, that's our function. And we want to solve when f of x equals 8. Okay, so that's this line way up here. This is the line y equals 8. So I want to know, when does our absolute value equal 8? Where do they intersect? Where will this line and this graph intersect? Never, right? Imagine that this is going to continue to go down. Okay, so this one would have no solution, right? No solution because they don't intersect. Okay? Solve f of x is greater than 8. Greater than. So where is our graph above the line y equals 8? Never, right? It's all below it. So this is also no solution because it's never above. Okay, solve when f of x is less than 8. That's when is this function below the line y equals 8. Isn't it always going to be below? Imagine this extending out forever. It's still going to always be below that line. So the whole dang thing is part of the solution set, right? So we're not going to say no solution. We're going to say all real numbers, because our number line diagram would look like just a completely shaded in number line. Our solution is all real numbers, or in interval notation, negative infinity to infinity. Because the whole thing is under the line, right? Okay. Can y'all take a second and try example 4? I want you to try, there's nothing weird about this one. I just want you to try to see if you can write the answer correctly on your own. Because it's one thing to copy my answer, but it's another thing to try on your own and then adjust, okay? So just take a second and try this one, and then we'll go over it in just a second. Okay. So once you've had a chance to try it, you can look up here and see your notation, whichever one you chose, whether you chose to do the set notation or the interval, doesn't matter. Just check that you were able to do that correctly. Okay? Okay, any questions I can answer for you? We do okay? Okay, last one is looking at this at a table, from a table, okay? So we're not even given the equation of this function. We know nothing about it other than it's got this table. We want to solve when is f of x less than or equal to 2. Okay, so no graph, just a table. Well, f of x, that's this column, right? And I want to know when is it less than or equal to 2. So it's equal to 2 here, and it's equal to 2 here. Where is it less? In between these two dots or on the outside? In between, right? The number 1 is less than. Okay? So the answers are now the corresponding x values. So that would be right here. So when is it less than? Well, it's less than when x is between 4 and 6. So we'd have bracket 4, comma 6, or 4 is less than or equal to x is less than or equal to 6. Okay, now there's two embedded questions here. Solve when f of x is greater than 2. So when is f of x greater than 2? Whoops. Well, that's going to be a open circle. And I'm only looking at f of x, right? So here's where we equal to. And where's f of x greater? These are on the outsides, right? These f of x values are bigger than 2. So to get the answer, I look at the corresponding x's. So on a number line, it would look like this. Open circles, go into the right. So 4 and 6. So negative infinity to 4, parentheses, union 6 to infinity. Or x is less than 4, or x is greater than 6. Whichever method you want. You're not going to see the tables as much as you will the graphs, and that's because our main calculator, the Desmos calculator, is way better at graphs than it is at tables. So the only time you're really going to need to solve from a table is if it's like this, where it's like on the paper. Okay? Okay.